So everything we've done up until now has basically involved just a single table, filtering it, selecting values on it, creating, aggregating results. And sometimes we want information from more than one table, and this is where relational databases like SQLite become really useful. So for example, we have information in the surveys table about species ID. So we have these codes, NL, DM, and so on. And if we go to the species table, we see those same codes, but we also have other information like genus, species, and taxa. And so maybe we would like to have our results not with species ID, but labeled by genus and species. So what we want to do is join these two tables into a single result. And you see the wrinkle here is that so it's not as straightforward as simply selecting from one and selecting from the other and then sticking them together with cbind like we could do in R, because we have 54 rows in this table, but 35,000 rows in this table. That's because in the species table, each species ID is only represented once. It's represented many times. Each of them is represented many times in the actual surveys table. So what we really want to do is actually get that result, or get that sorted out by a different, where we want to stick them together by actually replicating one of the tables to match the other one. And so the way we do that, let's get to an SQL group here. So we're gonna select oops, here we go. So just select everything for the moment from the surveys table. Okay, so we want to get all of those rows, but we also want to know what are the genus and species and taxa from those things. And so what we do is we use the keyword join. And this literally means join these two tables together, or join surveys with something else. And in this case, the something else is going to be another table, species. Now we also have to give it a bit more information. We have to tell it which of the variables in these two things should match. And so we use the keyword on to do this. So, and we pull out our fields. Now we've got two tables to go, so we use the name of the table, then a period, and then the field name. Species ID equals species, period, species ID. So what this says is that we're going to take surveys, join that to species, and we're going to create that join by matching up species ID between the two tables. That took a little bit longer, 2.45 seconds. And so now what you can see is we now have our month, day, year, plot ID, species ID, sex, hindfoot, length, and weight. Those are all from the surveys table. Now we also have species ID from the species table, genus, species, and taxa. So now we've added up, and so you can see it's replicated that information into this table here. Now you might wonder, why wouldn't we just include the genus and species and taxa in the surveys table? And this gets at the question of what's called normalization. And by normalization, we mean to what extent can we minimize the duplication of data? So you can imagine that if we tried to enter all of this data this way, then every time we entered a new row, we would have to enter the month, day, year, plot ID, species, sex, hindfoot, length, weight, and then we would have to type all this other stuff out, or at least select it out of a list. That's very repetitive. Really, all we should need to do is say which species it is, what sex is, what hindfoot length and weight is, And all this other stuff can be stored in a separate table. All right, so the advantage of that normalization step means that you minimize the amount of data you have to enter. And moreover, let's say you misspell neotoma in one case. If you have it in a all entered into a single table, you have to find all of the instances where you've misspelled it and fix them, okay, and not change any of the other ones. If you have a single table where genus and species information is stored, then you just have to go into that one spot, change it there, and then it's all changed. It'll always be changed everywhere. So that's sort of the advantages, or some of the advantages of normalizing your data tables so that you don't replicate information unnecessarily. You can always pull it back together again, like we're doing here with a join. Now we might not want to, but there's a couple different ways that we can do this. There's a sort of a shortcut to this: on survey species ID equals species ID. We have a shortcut because the variable is actually the same in both cases. So if it was named differently, this shortcut wouldn't work. But we can actually, because it's the same, we can simply say using species ID, and that will give us the same result. In fact, it gave it to us slightly faster. Now, actually, one thing that's interesting here is notice that this number of rows returned, 34,000 something, is actually less than what we have in the original table. And that's because the species ID is not matching up wherever it is missing. Let's scroll down here. You see that species ID is always present. There's no missing species IDs, and that was in fact not the case in the underlying table. So if species ID is missing, it doesn't know how to match those up. It doesn't match the missing values with missing. The other difference with using species ID, you see, is that species ID now only appears once in the combined table instead of twice. So that's a bit of an advantage there. Now, we might not want all of the variables, so we can, in fact, using the same sort of table period variable name notation, we can sort of limit what we end up with. So, for example, we might want to have surveys year and species genus species. So here what we're doing is we're going to get just the genus and species by year. And actually what I'm going to do is add in a count. Oops, count. Well, let's not add that in right now. Let's just look at this. Let's just look at this result. Okay, so now we're still getting multiple observations of individuals, different species. And so what I want to do is I want to actually group by. I do want to count them. I want to know how many neotomas we had. But in order to do that, I need to do group by, and I can use species ID here. And that's worked out quite well. So now see, I have my genus and species and year. Oops, my years are all messed up. So I also want to order by year, and I want that to be ascending. And then I want genus ascending, and then species ascending. is it starting in 1984? Oh, because I'm only grouping by species ID. So see how many records I have? 48. So that's a dead giveaway. That's where you always need to check the number of rows returned. So 48, it's because I didn't put in the year. So I need to group by species ID and year if I want to know about the years. There we go. That makes more sense. So now I can see year, genus, species, and count. How many of this individual did I get in each of those years? And I had this sort of result before, but only using the species code. And these genus and species results are more useful, or easier to understand, I guess. It's easier to see that this is Dipodomys ordii instead of DO. Now, if you did a lot of working with this database, you'd know that DO was Dipodomys ordii, but this way you don't have to guess.